Okay, to start the process of requirements formalization, we start with a text document, which could include use cases or some data descriptions. Here we've got some very simple use cases or user stories describing some patient analysis system, which allows us to add a new user, add a new patient, and do some analysis on the patients and groups of patients. We feed that text file into a tagger, a part of speech tagger, which in this case is the Stanford NLP toolset tagger. And this is the command. It's essentially just to use tagging and not any of the other facilities here. The input file is this medicurve.txt that we just saw, and the output is going to be the tagged text. So that's a very quick process. What we end up with is the tagged result. And it's a good idea to put these on separate lines before putting them into the tool. You can see here that each of these words has been tagged with a verb or an adjective and so on. We expect in use case, each user story, each use case should have at least one verb, and that verb is going to determine what kind of use case it is. An add verb indicates a creation operation, an update indicates an edit. These have not got any verbs, so they're rather anomalous things. And indeed, if you're going through a requirements process, you might go back to the customer and say, well, what is actually meant by this? If this is a user story, it's not really a complete user story. And likewise, the last two, in a similar way, they don't have verbs. But we can still feed this into the tool and see what happens. So that's our input to the tool. We put that file in the output directory, which is below your tool directory. Wherever your tool resides, that output directory is going to be where all the data that's input and output to the tool is stored. We then run the tool, and the option is formalized behavior requirements. We run formalized behavior requirements. We get an analysis for each sentence. Here, sentence 4, it had an update verb. It's recognized various other words as being significant, and it's identified the actor of the use case as being update, which actually isn't right in this case, but here we don't actually have any actors in these user stories. So again, they're rather anomalous, but if there was a proper actor, then it would be recognized. The output is written to the metamodel file mm.km3. It's a textual form of a metamodel. We can load that into the tool by loading km3, and we get the graphical form of the model. Here the user stories have become use cases in UML, and some of the related entities have become classes, but some with data. One thing we can do here is view the dependencies between the user cases, user stories, and the actual entities. So here we can see that add new user writes the entity user because it's creating a new user. And if we actually look at the text form of these user stories and classes, There's also tracing here. We can see which sentence led to this class by means of the stereotype. If we look at the details of the use cases, we can see that we've created some initial post condition to say that this use case, add new user, actually creates a user object. And that's the result of the use case. So those are simply recognized as creational use cases. There's an update, and then these are unclear what they are. Okay, so that's the basic idea, and it's a way to form an initial model from a textual set of requirements in natural language as a starting point for requirements formalization and software specification.